Okay, so if I want to prove some parts of the triangle's congruent that correspond, if I prove the triangle's congruent, would those corresponding parts not then be congruent? Yeah. And we kind of touched on it before. What would be a reason to justify such a thing? Corresponding parts of triangles are congruent, right? Or to shorten your writing, what could you write in the reason column? CP-CTC. Now, CP-CTC, and I say this because I've seen it in the past, does not prove triangles congruent, right? Side angle side does not prove angles congruent. What does side angle side prove? Proves what congruent? Triangles congruent. And only triangles congruent, right? Okay. Well, let's look at some examples because now we have some more tools in our belt for reasons. So in this first example here, they tell us that AB is parallel to DE, and they've marked them parallel. Hey, now we know something about parallel lines, don't we? And now could these be considered transversals? With some angles in there that we know about now, right? Okay. All right. Now they want us to prove, oh, and they also tell us that BC congruent to DC. And they've marked it. They were nice enough to mark it, right? So they want us to prove that AC is congruent to EC. Here's AC, and here is EC. Well, those are corresponding parts of triangles, aren't they? Right? Yeah. So what should we do first? What? What should we do to prove that AC is congruent to EC? Prove that the triangles are congruent. And then these would have to be congruent because why? CP-CTC, right? So, okay, let's think about how to prove these triangles congruent. We've done this before earlier. So, before we start thinking about writing anything, let's make a plan. We don't have enough given here to say they're congruent, right? But we know that those two segments are parallel. So, given that those are parallel, are there any angle pairs that would be congruent in here? Angle B would be congruent to angle D, and A would be congruent to E. Why would those angle pairs be congruent? Because if lines are parallel, then what? No. What did we just learn? Lines are parallel. We didn't say segments were congruent. Huh? So if lines parallel, alternate interior angles congruent. Now, wouldn't B and D be congruent for the same reason? If lines parallel, alternate interior angles are congruent. Now, does that give us enough to say that triangles are congruent? Well, angle, side. Triangles congruent, right? Now, since the triangles are congruent, what can you say about AC and EC? They're congruent. Why? Right? So here's our proof. Of course, the given. Right? Parallel, these guys are congruent. Now, these are going to be, these angle pairs are going to be congruent for the same reason, so I rolled them into one, right? And one right was number two, but okay. If lines parallel, alternate interior angles are congruent. Wouldn't that go for both of those pairs of angles? Okay. Now, sometimes kids, instead of doing like they'll do one of these pairs, and this is fine too, right? So maybe instead of doing that pair, they say, okay, these are congruent because alternate interior angles are congruent, but then these are congruent. Why? Why would those angles be congruent with X smart? Because vertical angles are congruent, right? That's another way. But it wouldn't be, well, I can say it still would be, right? Would it still be angle, side? You could have picked. But now that would be an extra statement in reason, wouldn't it? you could do that, but like I like to think ahead, right, and shorten my writing. If I can see like two statements, I can roll into one reason, I'll do that. You could have done like this, like A and E congruent for that reason, and then angle BCA congruent to DCE because vertical angle, but you see that's like another statement, a reason altogether. Still valid, still work, right? But it's nice to shorten your writing if you can, okay? All right, kind of get the idea there? Let me put those back on there. So these were congruent. All right, let's look at the next example. Nothing's really labeled in here. So we have AC congruent to EC. Let's mark those congruent. And BC congruent to DC. Okay? Now I know what the tendency is going to be here for some of you. I'm betting some of you want to be able to say that angle B is congruent to angle D, right? Right? Because they look like alternate interior angles, yeah? Okay. I want to draw your attention over here. Over here, we said these two pairs of angles were congruent because why exactly? If lines are parallel, you must write that. Right? Because the only time that they'll be congruent, remember when I gave you that, I told you I made the lines not parallel to begin with, the last lesson, right? And they weren't congruent then. The only reason they're going to be congruent is when the lines are parallel. Got that? So your reason for that would be if lines are parallel. Well, coming back to this one again, do we know the lines are parallel for some specific reason? It says it, doesn't it? Okay. Is there anything in the given or anything else that says anything's parallel? No. So can we use the, can we do alternate interior angles or congruent in this one? No. No, because we don't have parallel lines, right? You gotta have parallel lines to that. Everybody got me? Yeah. Okay. That was gonna happen. You're gonna do homework. Okay. So from what they've given, then we don't quite have enough to prove them congruent. Is there anything else we can find in there? Okay. What? Specifically, what's congruent to what? BCA is congruent to BCE. Yeah, well, vertical angles, just like the old ones, right? So they're congruent. Are the triangles now congruent? Yeah. The triangles are congruent now by what? Side angle side. And so now they want to prove an angle B is congruent to D. Why? Right. You cannot have this, by the way. You cannot use CPCTC until you show what? Well, what does this say? Corresponding parts of what? Congruent triangles. So before you, listen very carefully, before you ever use CPCTC for a reason, you must have stated what first before that? Oh, that you have congruent triangles, right? You see this line right here? Without this line, where it says triangle BCA congruent to DCE, I can't use that. Does that make sense? The CPCTC refers to congruent triangles. You must have stated somewhere that the triangles are congruent. Proven it, okay? CPCTC always has to follow a statement of triangle being congruent. Okay? Does that make a little sense? All right, let's go over to the next page. Here's a couple for you to try. Let's work on this first one, okay? Now, we had one in the homework yesterday with some angle bisecting stuff, so hopefully you know how to deal with that, right? Okay? So take a look at this. They want you to prove that angle B congruent to D. So what are you going to go about proving first? Generally, here. Well, angles B and D are part of what shapes? Triangles. So what are you going to do first before you prove that B is congruent to angle D? What? A little out of here. Make a triangle? We got it. What are we going to do with those triangles? We're going to prove them congruent. like we did in last night's homework. But now we just have one more step. We have to prove them congruent before we can say B and D are congruent. Okay. By the way, I'm going to show you all a shortcut. You kind of saw it before, but instead of like having to name angles with 3 letters, okay, you can do the following. Everybody paying attention? I might call this angle here angle 1 and angle 2. And that way, in my statements, instead of having to say, you know, angle BAC congruent to angle DAC, I could say angle what? Congruent to angle 2. If I'm going to do that, I have to have them labeled clearly in the diagram as 1 and 2. If I say angle 1 congruent to angle 2 down here, without having it in the diagram, I get no credit for it. Okay? So if you're going to use that shortcut, it's got to be in the diagram. All right? Okay. I'll mark the other given in this one, and that is what? AB congruent to AD. We probably just need to find one more congruency in there to get the triangles congruent, and you're on your way. So what's the other congruency in here that we need to get the triangles congruent? Okay, AC is congruent to AC. What would be your reason for that?
Because of the reflexive property.
Okay. Will that allow us to then get the triangles congruent?
Yeah.
By angle bisector is not a reason for congruent triangles. What? They're 1 and 2. Are they stated congruent anywhere here? No. So you have to make that statement, don't you? Right? Let's get the given in here then. So 1, so here's the first statement. AC bisects angle DAB and AB congruent to AD. Reason for that statement? Given. And again, nowhere in the given does it say any angles are congruent. So what should our next statement be? No. Well, we could, but based on this bisecting part.
Angle 1 is congruent to angle 2.
Angle 1 congruent to angle 2. Reason?
Definition.
There we go. Definition of angle bisector.
And then
Yeah, we could have done the reflexive property one before that one. That order doesn't matter, right? But I was there. So what's our next statement?
AC
Congruent to AC.
because of the
Reflexive property. Yeah, we're cooking.
And then for it will be the proof, right? ABC, AC, triangles.
Okay, so now we have enough to say our triangles are congruent, right? Okay, so let's say that, because before we use CPCTC, the CT part we need to state,
Oh,
right? We haven't stated it yet, so we're going to say triangle ABC, and we need to line this up, right? Because if we're going to use, these need to be corresponding angles, so this statement has to be right. So ABC congruent to triangle what? DC, right? Because look, B and D, they need to be in the same position, right? And that would be the reason side, angle, side. We're not done. We've got the triangles congruent. Well, we would only be done if our last statement was what they wanted us to prove.
And then we would do
What can we say now? Angle B congruent to angle D. Reason? CTC. Why can we use CTC? because we stated that we have congruent triangles, right? And by the way, real quick, back here, before we said SAS, right? How about this first S? Is there a pair of sides stated congruent?
Yes,
Right there and there. For that A, is there a pair of angles stated congruent?
yes,
Here. For the other S, we have a pair of sides stated congruent.
yes.
So we can use SAS, right? They all have to be. So a lot of your proofs come with just, missing an S or an A or something stated, okay? All right, so that's how that works. Move on to number 2. I'll go ahead and mark my given in the diagram here. So C is midpoint B, E. Oh, and that's key, isn't it? The and part, isn't it? So that means, that means they're congruent. And these guys are congruent, right? The only, like, a lot of times you'll be tempted just to put all those congruencies in there like I did, but you can only do so if it's the midpoint of both of them, right? Okay. I'll get the given written down since got to have that anyway. So C is midpoint of AE and BD. AE and BD. So I can abbreviate the given as long as it's all there. You have to, but it's all got to be there in this episode. You can abbreviate. So before we get AB congruent to DE, what do we have to prove first? Triangle's congruent. Do we have enough information for that? No. We've only got one congruency, don't we? We don't even have that. We're not given anything congruent, nothing in the given. So we have no congruencies, do we?
Not yet.
Not yet. Well, what's congruent in there? I marked it already, even though it's not the given.
BC is congruent to CE.
Yeah, and what else?
AC is congruent to CE.
Why would those two pairs of things be congruent to each
So
other?
that's definition of midpoint.
There we go, and I can wrap them into the same statements. It's the same reason, right? Okay, let's do that. So we got 2. I guess I spilled over from the other one. I can say AC congruent to DC, and the other one would be, oh, not AC and DC. No, I'm thinking of the band. AC congruent to EC, right? And then, what's that top letter? Oh, BC to DC. BC congruent to DC. And you said,
Definition
yes,
of
definition of midpoint. That's a D, not a P. Okay? Okay, we need some vertical, right? We need another congruency. What will it be?
BCA and BCE.
Let's do this.
Wait, could you just do angle 1 and angle 2?
Yeah, let's do that. So what's our next statement?
Angle 1 is congruent to angle 2 because of vertical angles.
Vertical angles what?
Are congruent.
Yeah, you got to have that, right? Angle 1 congruent to angle 2. Reason, not just vertical angles. Vertical,
Angles,
yes.
which
Congruent.
now that gives us another.
You get the triangles congruent by what? Yep. Now let's make sure we get the triangles named correctly, so that we have A, B, and D, E corresponding, right? So for triangle, what? What do you want to say?
Don't we want C in the middle?
Doesn't matter as long as you get them all lined up right in the naming.
So it does CBA.
Okay, let's do CBA, triangle CBA. Doesn't matter how you start. Now we have to make sure the next one corresponds with C and B and A. To triangle CBA to CDE. Everybody see that? CDE. Because now look. All right, you see AB up here? and DE?
Yeah.
So AB is in this position here, or is D and E in the same relative position in the other one?
Yeah.
Okay, so right, so our naming correspond, right? What's the reason for this statement, by the way?
SAS.
SAS. And now, what they want us to prove, right? AB congruent to DE by what? Say again?
CP,
There you go. 5 CPCTC. Okay? So it's basically one more step from what we did yesterday, right? Yesterday, we worked on proving triangles congruent. Now we have to use congruent triangles to get the congruent corresponding parts, the CPCTC. So basically one more step. All right? Is there another example on this one? Everybody got that?
No, I'm just reading.
Regents questions, okay. Again, I don't think there are any proofs in the Regents questions, if you still on the simple side. But we'll get there. Okay, let's look at, there's only two of them. Yeah, perfect. Let's look at our first Regents question. Read it, and I would definitely mark the diagram they give you, anything they tell you that's congruent or whatnot in there, right? Parallel. Anything to mark congruent here? Yeah. Is there anything congruent in here, no matter what they tell us?
Yeah.
What?
And K and KC.
NK,
Oh, vertical.
NKA, and
KC. And C. No,
wait. NK, segment NK and segment KC?
No.
No.
Try. It is a NKA.
NKA and angle and
SKC.
because vertical A, right? So no matter what they give us, we know that's going to be part of it. We need it, right? We don't have to use it, but it's going to always be there. Okay. Now, and read carefully. What's key here? Prove these triangles congruent exactly specifically by what? Angle, side. So which of these, right, would cause them to use angle, side? Go through them each.
Because it's a parallel line.
All right, well, let's take 4 and mark these parallel. So the fact that they're parallel, does that make the triangles congruent?
No.
No, but we know stuff about parallel lines and transversals and angles form, don't we?
Yeah. So
Okay.
It's alternative.
Okay, so tell me what things would be congruent given that these lines are parallel.
Wait, sorry, say again?
Given that force wants the lines to be parallel, what in the diagram will be congruent since those lines are parallel?
Angle.
A and,
C and then.
wait, A congruent to C?
No, A and S, right?
A and S because they are what? Alternate interior angles.
Oh,
Anything else?
and then I can see.
Oh, I should have used double there.
Then triple.
All right, will that get us angle, side?
Yeah.
It'll get us angle, side, angle as well, won't it?
Yeah.
Right? But we are going to need this pair, aren't we? To get angle, side, aren't we?
Yeah.
Right? Because if we didn't have these marked congruent, does that give us angle, side? No, that's angle, side, angle, right? But they wanted the other. So that 4 would do it. Let's check the other ones real quick. So let's check, let's get rid of this. Get rid of that stuff. Right? Let's check 1. A, S, and NC bisect each other. Not just one bisects the other, they bisect each other. So what does that tell us? It's congruent in here. These guys bisect each other, so what's congruent?
AS and NC. No.
No. AK and
Chaos.
KS, since they bisect each other, what else is congruent?
And K.
Well, that'll get the triangles congruent,
Yeah, but it wants it to be KAS.
not by angle, angle, side. Okay. Right, so let's look at the next one. K is the midpoint of NC. What does that make congruent? Will that get the triangles congruent by angle, angle, side? Will that make them congruent by anything?
Or no, because that would be AS.
That'd be angle, side, side, wouldn't it? So they can't use that one. What about 3? Curious about 3. 3. What does that say?
AS.
What does that symbol mean? Hmm?
No, that's segments of the line problem.
Perpendicular.
Perpendicular now.
Which means what kind of angles are formed?
Right.
Right angles. So wouldn't that be a right angle?
Yep.
And that one? Well, does that get us any further, really? I mean, all right angles are what to each other? Congruent. And they're already congruent because, they're vertical angles. Right? So that doesn't really help us, okay? All right, so the answer is 4. Thank you, Aiden. On to the next one. You guys remember what it means if rigid motion maps things onto things? What does that mean? What the rigid motion maps things to things, what do you know about the things? Yes, right? It's another way. They don't say congruent, but remember, the rigid motion they map, they're congruent. So I would mark those. Wouldn't A and X be congruent? And C and Z be congruent, wouldn't they? Use a double mark. And AC and XZ would be congruent, wouldn't they? Have to. So would BC be congruent to YZ?
Yeah.
Why?
Yes, over just because there's a. Well, I think we did one exactly. Rigid motions.
Well, right. If BC was to be congruent to YZ, wouldn't the triangles have to be congruent?
So yes.
And also, so the triangles have to be congruent, and BC and YZ would have to be corresponding parts. Congruent. Now, let's start with the first part. Would the triangles be congruent?
Yes.
By what? False.
Wait, no. Side.
No.
Angle side.
Angle, side, angle. Okay, so the triangles are congruent. Now, we need to determine whether BC and YZ correspond to each other. Look at this up here. Does BC match up with YZ in their statement?
Yes.
So they are corresponding parts of congruent triangles, and therefore they are congruent. So let's answer this thing. What are we going to say?
Yes. Because the
So triangle, what? ABC
because
congruent to
XYZ.
XYZ by
Angle side.
angle, side, angle. So BC congruent to YZ by CPCTC. Corresponding parts of congruent triangles are congruent. Okay? All right. So your problem, oh, it's almost time to go. I'll give you your problem set then.